Hello grade 10s and welcome back to another video with me, Natasha Barton. In this video we will take a look at what pure substances are and we will distinguish between elements and compounds. Let's start off by defining a pure substance. We say that this is a substance that cannot be separated into simpler components by physical methods. Now, what are physical methods? Well, these are the methods that we can use to separate the components of a mixture. Methods or physical means of separation, including filtration, evaporation, distillation, and hand sorting, can only be used for mixtures. But in order to separate the components of a pure substance, like a compound, we will need to make use of chemical methods, or in other words, chemical reactions. There are many different methods that we can use to check if a substance is either a pure substance or a mixture. One of these methods is called paper chromatography. Using this method, we can clearly see that ink from a black marker or black Koki pen is actually not a pure substance. If we make a mark on the special paper that we use for paper chromatography, and then submerge a small part of that paper in water, what is going to happen is that the paper is going to absorb the water, and the water is going to slowly move up the paper. When it does so, we see that the ink is separated into its different components and different colors. That is because the different components have different degrees of solubility in the water. And using this method, we can clearly see that ink from a marker pen is not a pure substance, but a mixture. Another means of checking if the substance is a pure substance or a mixture is by making use of the boiling and or the melting points of different substances. For example, water at standard pressure. Standard pressure is 1,013 times 10 to the power of 5 Pascal. At standard pressure, water will have a melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. That means that when the temperature is lower than 0 degrees Celsius, then water is going to be a solid. If it is between 0 degrees Celsius and 100 degrees Celsius, then we will have water in its liquid phase. And if the temperature is higher than 100 degrees Celsius, then the pure water will be in the gaseous phase. But if we add something like table salt to the water, then what is going to happen is that the water will not necessarily melt at 0 degrees Celsius, and it will not begin to boil at 100 degrees Celsius. We will find that the boiling and melting points change because of the presence of sodium chloride or table salt in the water. And based on this, based on the fact that the boiling and melting points are not what we expect, we know that the water is not pure water. If we compare the different boiling and melting points of different substances, we see that they are different. For example, acetic acid has a melting point that is higher than that of water. When acetic acid is at a temperature of about 16 degrees Celsius, it will still be a solid. But when it is at a temperature between 118 and 17 degrees Celsius, then it will be a liquid. If the temperature is higher than 118 degrees, then the pure acetic acid will be in the gaseous state. If we look at a substance like ethanol, we see that ethanol begins to melt at a temperature much lower than the melting point of water. Specifically, at negative 114 degrees Celsius, ethanol will begin to change phase. If the temperature is lower than negative 114 degrees Celsius, then ethanol will be in the solid phase. But if the temperature is negative 100 degrees Celsius, ethanol will still be in the liquid phase. At 0 degrees Celsius, it will still be in the liquid phase, and at 77 or approximately 77 degrees Celsius, it will still be in the liquid phase. But if we go to a temperature higher than 78 degrees Celsius, then ethanol will be in the gaseous phase. As you can see, different substances have different boiling and melting points. So based on this, we can use the different melting and boiling points of the different substances under standard pressure to see if the substances are pure substances or if they are mixtures. And of course, if the boiling and melting points are not what we expect, then we know that there are impurities in the substance. Pure substances can be classified as either elements or compounds. We say that an element is a pure substance consisting of one type of atom. So as an example, we have a block of gold and we have gold coins. When we look at a block of gold, we know that it is made up of gold atoms. Now, since it is made up of so many gold atoms, many learners tend to think that a block of gold is most probably a compound. But what type of atoms is a block of gold made up of? Well, it is made up of only one type of atom, specifically gold atoms. So therefore, a block of gold is classified as an element. If we look at gold coins, contained in the gold coins, or what the gold coins are made up of, is gold atoms, a whole lot of gold atoms. Since this is only one type of atom, we can also say that gold coins are an element. Another example of a pure substance is diamond. Here I'm referring to diamonds like those that are mined out of the ground and that are used in jewelry, such as the image displayed to your screen. Now, diamonds are made up of only one type of atom, and between these atoms are very, very strong chemical bonds. Diamond is made up of carbon, and it only contains carbon atoms. Therefore, we can say that diamond is a pure substance. Graphite, which is found in pencils and is actually the component of pencils that we use to write with, is also a pure substance. We often refer to the graphite in pencils as pencil lead, but it is not made up of lead, it is actually made up of graphite. Graphite is made up of only one type of atom. Specifically, it is made up of carbon atoms. And since it is only made up of one type of atom, we classify graphite as an element. Did you notice that both diamond and graphite are made up of the same type of atom? They're both elements made of carbon. Since they are made up of exactly the same type of atom, we have a special name for substances like graphite and diamond. We say that they are allotropes. In this case, we are dealing with allotropes of carbon. The difference between these substances is not the type of atoms that they are made up of, but rather the way in which these atoms are bonded. When we look at graphite, we see that we have sheets of carbon with strong bonds between these sheets or these layers. But between the separate layers are bonds or forces that are not very strong. And this is why the sheets of graphite glide off onto your paper as you write. But when we look at diamond, which is a very, very hard substance, we see that between the atoms in diamond, we have very, very strong chemical bonds. And that is why diamond and graphite look so different and have different properties. We can write with graphite, but we can't write with diamond. Let's now take a look at the definition and a few examples of a compound. We say that a compound is a pure substance, just like elements, but this pure substance is a pure substance consisting of two or more different elements. So an element is a substance that contains only one type of atom, but if we look at a compound, it contains different types of atoms. A good example of a compound is the water molecule. The water molecule is called H2O because it contains one oxygen atom that is bonded to two hydrogen atoms. In a mixture, which is not a pure substance, we have that the different components can be mixed in any ratio. But when we look at a compound, the ratio in which atoms bond is extremely important. If we are looking at water, which contains hydrogen, and oxygen atoms, we see that the ratio in which they bond is 2 to 1. In other words, for every one oxygen atom, we have 2 hydrogen atoms. That is how they bond in order to form the water molecule. But if we go and we change this ratio, we are no longer dealing with the water molecule. For example, when we look at a substance like hydrogen peroxide also contains hydrogen and oxygen. But instead of having only one oxygen atom, it contains 2 oxygen atoms that are bonded to each other, and then it also contains 2 hydrogen atoms. The properties of water and hydrogen peroxide are very different. We can use hydrogen peroxide to bleach our hair, in other words, to change the color of our hair. But if you put water on your hair, all that is going to happen is that it's going to become wet. So as soon as we mix up the ratios of compounds, we are no longer dealing with the same substance. The ratio in which the elements bond is very, very important and will dictate which compound we have in our container or which compound we're going to be using to perform our chemical reactions. Another example of a compound is a sugar molecule. Specifically here, we have an example of a glucose molecule. You must be very careful with the word molecule because molecules are specifically compounds that are covalently bonded. This means that the electrons that take place in the bonding are shared between the different atoms. We're going to look at the different types of bonds in more detail in the chapters that follow. But for now, I just wanted to point it out just so that you start to get comfortable with the different words. If you look at the glucose molecule, you can see that it contains different types of elements, in other words, different types of atoms. Specifically, it has a carbon atom or different carbon atoms, or not different carbon atoms, but many carbon atoms in its structure, specifically 6 carbon atoms. It also contains hydrogen atoms, specifically 12 hydrogen atoms, and the glucose molecule contains oxygen atoms. Now, since the glucose molecule contains different types of atoms, or in other words, different elements that are bonded to each other, we can say that glucose is a compound. The last example of a compound that we're going to look at in this video is table salt. Now, the word table is actually very important because, grade 10s, there are different types of salts. Table salt refers specifically to sodium chloride, which is the salt that we put onto our food to give it flavor. We know that table salt, or you might know that table salt, is actually ionically bonded. So you get different types of bonds. You get covalent bonds, ionic bonds, and metallic bonds, which we will discuss in a lot more detail in the chapters that follow. But ionic bonds are basically bonds that exist between ions. Here the term ions, or the word ions, is spelled like this. Ions are basically atoms that have charges. So when we look at table salt, it contains the sodium ion and it contains chlorine ions that are bonded together. Now, since table salt contains different elements, specifically sodium and chlorine, we can say that table salt is a compound. Table salt, or in other words, sodium chloride ions, bond in an ionic crystal lattice like the one displayed to your screen. And basically, the formula NaCl tells us that for every 1 sodium ion in this crystal lattice, you're going to find 1 chlorine ion. You can see here is 1 sodium ion, then 1 chlorine ion, 1 sodium ion, 1 chlorine ion, and so on and so forth. This is how sodium chloride forms and how most ionic compounds form. But again, we will discuss that in a lot more detail in the chapters that follow. This brings us to the end of this video on pure substances. In the next video, we're going to look at a section that a lot of learners I find struggle with. This is how we name and get the formulas of different substances, different compounds.